Good morning, good afternoon, good evening, wherever you might be, and welcome to another science post. This one is for a general audience. You don't have to be a scientist to understand this one. It's called Keeping Warm with Starlight. During a long, dark night of the soul, what would you say if I told you that the stars are just atoms in the quantum vacuum, written large across the sky as a result of our vibrational motion relative to an absolute reference frame? You'd say I was nuts, right? Well, I'd reply, that's one way to put it. I just like a nice mental stretch sometimes, that's all. We prefer to think of stars and atoms as actual objects that exist rather than as illusions caused by our motion relative to something absolute. But when is it possible to describe something in several different ways without being, when it is possible to describe something in several different ways without being wrong about any of them? Maybe there is something worth thinking about in this description. It isn't terribly controversial to suggest that the dipole anisotropy of the cosmic microwave background is caused by our motion relative to an absolute reference frame. But going one step further and suggesting that the whole night sky is caused by motion relative to an absolute is a lot harder to swallow, even though it is consistent with some well-developed theoretical frameworks. In the blog post, I have some images of the night sky around our planet, and they are taken by satellites placed as far away from the Earth as possible. Where you see diagonal asymmetry of the light coming from the motion of our solar system. And you see that after subtracting out the light from our galaxy, the Milky Way, and the signal from our solar system's motion relative to an absolute reference frame, the light around the detector is relatively homogeneous and just kind of noisy. And we're told that this image of the noise in free space is the leftover heat from a big bang and a gigantic explosion at t=0. We are told that flashes of gamma rays within this picture represent exploding or merging objects of enormous power. We are told to search for meaning in this image of the noise floor of empty space. But, like art critics, staring at a Jackson Pollock painting, I feel like such images are a representation of a search for a reflection of our empty souls, looking past a rainbow and into the noise. People today are taught to imagine the cosmos as a gigantic explosion of immense and terrifying power, much like an atomic bomb. They also like to imagine Star Trek-style interstellar travel. But people of the future might think we were weird for believing this instead of something else. Who knows? I can even imagine a religion founded on the 8 principles of octopus mind control. Religions don't have to make that much sense. They just have to be comforting and give you a sense of order. The temperature of an object approaches absolute zero as its energy or speed increases. And this is why empty space has a minimum temperature of around 3.7 degrees Kelvin. If empty space had a temperature of 0 degrees Kelvin, it would have infinite energy. In fact, many particle physics models approximate the energy of the quantum vacuum as being infinite, because physics models are, of course, approximations of nature. When we try to describe what we see, we can say empty space is moving around and vibrating very fast relative to us, and that is why it looks so cold to us. The motion of this empty space can be approximated as an expansion, but it makes more sense to think of it as a vibration, in which space itself is vibrating, and the stars are pulsating in opposition to the vibration of space. This is the alternative to saying that space is expanding. Vibrating space and expanding space act very much the same in many frameworks. It makes sense to say that things that look stationary to us are merely vibrating in sync with us. And this is what scientists from the past, like Maxwell, Heaviside, Bjerknes, and Hertz, saw when they looked up at the sky and imagined that it was filled with a sort of jiggling jelly ether. That's what ether was to them. It was something in which, a substance in which matter exists. That's not the same thing as a luminiferous ether, a substance in which light exists. So if you break things down sensibly, you see that the ether is a jelly made of light in which matter exists. But if it's made of light, then doing something like the Michelson-Morley experiment it can't detect itself. You know? It's not that complicated, but teachers have to use the right heuristics. The ether is made of light. It acts like jiggling jelly. Matter exists in the jelly. Something like that. To a physicist from today, the use of the word vibration sounds like New Age nonsense, but it is actually a technical term, just like all of the terms they learned about harmonic oscillators. The word vibration has just gone out of fashion. It sort of became a fnord. To us modern folk, empty space is cold while we are hot. But relativity tells us that to empty space, we are cold and it is hot. We look at each other through a mirror on the wall, in which up is down and down is up. On the other side of the looking glass, absolute zero is the hottest temperature allowed, but it looks cold to us because we are not moving as fast as it is. This is all consistent with the math of physics, but it sounds rather strange when it is put into words. Maybe that is why physicists insist on speaking exclusively in the language of math. Cognitive dissonance hurts, and if you only select physics teachers who avoid that pain by focusing on math while being incapable of imagining the two sides of a mirror, you will end up with a rather one-sided picture passed down through the generations. The hotter the fire, the stronger the draft is a simple concept that anyone can understand, And that is what a vacuum is. It is the strongest draft we can create with the heat of the stars. Alternatively, one might say that the heat of empty space creates rapid drafts or motion within the stars, and these are the two sides of the looking glass. Expressed in more poetic form, inspired by Plato's cave allegory, I wrote this little bit here. Clouds, ghostly muses born of Zeus's lightning, are thoughts condensing in our minds. Precipitated by Apollo's light, these immortals cast shadows that determine their future forms. In Plato's cave, we fear such shadows of ourselves, knowing their power to bewilder and ensnare. By Prometheus's firelight, we tell ghost stories to remind ourselves of things that can't be said. It is not unusual to model the universe as a thermodynamic system in which space expands adiabatically like warm breath on a cold winter day. But this story doesn't tell you what happens when a photon from our sun hits Alpha Centauri. Does this violate the second law of thermodynamics? Or is the system not closed? In solid-state physics, sound carries mass in the form of phonons, and if gravity is powered by the vibrations or phonons contained in empty space, do these vibrations or phonons carry mass between adjacent stars? Can linear momentum be treated as a very low frequency, high amplitude oscillation? Does energy density depend on how much the measurement apparatus is shaking? Is what we see in the night sky created by how much we are shaking or by how much it is shaking? Does the difference matter? These are old, rather simple questions, just like the question of why the night sky is dark, and the question of how much heat empty space absorbs from the light of the stars. If you look back into the 1800s, you see that there were already quantitative answers to these questions. But 100 years later, physicists had forgotten these answers and were surprised to rediscover that empty space wasn't completely empty. It had a temperature. And most physics students today don't know this part of physics history. I encourage you to click on the blog post and look at the timeline of what we've understood about the heat of the stars. Even back in 1896, Charles Edward Guillaume estimated that the heat from the radiation of the stars was between 5 and 6 Kelvin. This is not too far away from the 2.7 degrees Kelvin that we know today. And in 1926, Sir Arthur Eddington estimated the radiation from starlight to be 3.1 degrees Kelvin. This is even closer to our present day accepted value of 2.7 Kelvin. Then in 1930s, Erich Regner estimated that the galaxy had a temperature of 2.8 Kelvin. Now we're even closer. And by 1931, it was understood that the wavelength of this was in the microwave range. Then the World War happened, or the Second World War rather. And by 1934 and by 1938, these old estimates had been somehow forgotten or ignored, and the estimates became quite different. Walter Nernst even won a Nobel Prize for estimating the temperature as 0.75 Kelvin, which is quite wrong in comparison to the estimates his predecessors had made. Then in 1946, Robert Dicke was even more wrong. He estimated it as around 20 Kelvin. By 1946, they were even more wrong. They were estimating 50 Kelvin. By 1953, someone remembered the old estimates. A person who was named Erwin Finlay Freundlich. He was trying to rebuild a steady state universe theory in the form of tired light theory, in opposition to the more commonly accepted Big Bang theory. And he derived a more correct value for the temperature of empty space compared to all of these people who had been making bad estimates after the war. So he remembered. He was reconnecting to pre-war physics foundations, and he got the right number. Whereas there was a whole community that had somehow gotten completely lost in the aftermath of the world wars. But today, that's the real story of the detection of cosmic microwave background radiation, otherwise known as the heat that empty space absorbs from the stars. But today, most physics students only know the story of Penzias and Wilson, two young American men who won the Nobel Prize in the 1960s for measuring the 2.7 degree Kelvin heat. But from an experimental standpoint, they were horrible experimentalists. I mean, they were trying to use a radio wave antenna and to measure the stars, but they kept measuring a bunch of noise. And they didn't understand that what they were measuring was the light of the stars, the light that empty space absorbs from stars. They thought that they had a problem with their measurement device, and so they scraped bird poop off of their antenna and tried a bunch of other things, but they couldn't get rid of this noise. Then they consulted another physicist who told them how to interpret it. They had no idea. Dicke explained to them. And once they did that, they somehow, by properly calibrating the device or tuning it until it got the right answer, they arrived at the 2.7 degree Kelvin temperature of empty space. This is the quality of science that has defined the Nobel Prize ever since, as far as I can tell. Students are taught that these two people were good scientists, but who really estimated the temperature of empty space first by using empirical methods? Was it Kelvin? Or, I mean, this is ridiculous. Why do we keep forgetting things and then rediscovering them and And after this, I have an even more detailed timeline of how confused people got about this measurement. Even in the 60s, up until the 60s, people were still getting wrong values for it. There were like 1946, 50 Kelvin estimate, 1948, 5 Kelvin estimate, 1949, 28 Kelvin, 1953, 7 Kelvin, 1956, 6 Kelvin, 57, 4 Kelvin, 1960, 40 Kelvin. It just keeps going. And were they getting this value wrong on purpose? In any case, they gave a Nobel Prize for what was a terrible experimental design, and this model has been repeated many times. In the case of LIGO, you have another Nobel Prize granted for a terrible experimental design. And when I look at other Nobel Prizes, for example, for neutron stars, antimatter, I just get more and more disappointed with the community and how groupthink infects it. The individuals may be surprisingly clever, but when it comes to complex topics, an individual who defers to a group can be surprisingly stupid. Dirac didn't even believe in the interpretation of the equation for which he was given a Nobel Prize, yet party politics forced him to fall in line with the group in order to be given his $1 million award. This sort of thinking will lead me down a rabbit hole I'd rather not enter, so I will return to focusing on the warmth of empty space and how it relates to starlight. Okay, back on track. The evenness or isotropy of the observed starlight absorbed by empty space or cosmic microwave background radiation convinces lots of people that it is not a local effect. But truly, we can't rule out the possibility that this is just a property that exists where we are, not everywhere. Research done by a nuclear magnetic resonance imaging specialist from outside of the field of cosmic microwave background radiation analysis, he's from outside of the physics community, he was critical of the claims made by the cosmologist. He believed that the satellite measurements were, based on his understanding of physics from using a different apparatus, he believed that they were detecting radiation emitted by the Earth, despite their best efforts to avoid doing so. Because there is no control variable for this experiment, it is impossible to rule out such a claim, so he could be perfectly right. The sort of physicists who place their full trust in the establishment typically scoff at the journal he chose to publish in because it often hosts non-mainstream ideas. But I think that the incentives of cosmologists to protect their expensive research may have proven too powerful for him to get past their reviewers. I haven't seen the full debate nor seen the rebuttal from the cosmologist, but I put some links to all the papers in the blog post. And I would not be surprised if their rebuttal technique was simply silence. Silence is usually an effective method to discredit ideas that threaten your funding supply. I do know that he is not allowed to attend standard conferences. He is very much ostracized from the community. Without suspicions of the measurement showing us a picture of local space rather than the entire, without suspicions that the measurement only shows us a picture of our local space rather than of the entire universe, there are still reasons to doubt the measurement based purely on the experimental methods used. For example, the Nobel Prize-winning COBE experiment drew my suspicion because they brought a black body source up into the coldness of space to calibrate their measurement. Just think about this for a second. That's not legitimate. They measured a perfect black body spectrum in the coldest place they could get their detector to, they could put their detector. They measured a perfect black body spectrum while using a perfect black body for calibration. You can't do that. In their measurement, a person named Smoot measured anisotropy, the evenness, so a picture of space. And this is a relative measurement, and that sounds possible. But the other person who won the Nobel Prize that year, Mather, claimed an absolute measurement with an unbelievable accuracy of 2.725 plus or minus 0.001 Kelvin. Now, when I write unbelievable, I literally do not believe that he measured what he claimed to have measured, because he put a calibration device, he basically just measured his calibration device and claimed that he'd measured something else. Despite quiet, polite doubts from their contemporaries, these two guys, Smoot and Mathers, still won the Nobel Prize in Physics. And I have a quote from the Nobel Prize acceptance speech in which he describes how a small warm calibrator body could be moved over the aperture to measure the sensitivity of the instrument. Oh, God. I wouldn't have a big problem with seeing sloppy scientific methods. I mean, it happens. If I didn't also have to see the results of such experiments glorified by prizes and the media. It is bothersome that nobody who gave the OK signal for this Nobel Prize has had the courage to come out with any admission of reasonable doubts. So I have also a quote from Difficulties with the Planck satellite. So COBE was the first satellite, then there was WMAP, and then there was Planck. And then the Planck people were quite direct about what they were doing. Millimeter radiation is emitted at some level by all objects. This means that, as well as detecting the cosmic microwave background, the Planck instruments will also detect the emission from the satellite and even the detectors themselves. To reduce this emission, the instruments are cooled to cryogenic temperatures at just 0.1 Kelvin. So, without this, trying to detect the cosmic microwave background would be like trying to take a photo while shining a bright torch into the camera lens. Simply by being out in space and shielding itself from the sun, Planck can cool down to around 50 Kelvin. One fridge will then cool it down to 20 Kelvin, with a further 2 devices cooling various parts to either 4 Kelvin or 0.1 Kelvin, using helium to achieve such low temperatures. As an experimental design, this is horrible. It's just awful. I mean, it's written right there. If you interpret those words correctly, you understand that this experiment cannot work. And this sort of scientific fraud doesn't even have to lie about what it is doing. They directly state what they are doing. But most people can't be bothered to figure out what they are actually saying. Because they've turned their language into so much technical noise. Perhaps those who should have been paying attention were distracted by a movie or some other source of cultural noise, but what is the purpose of this noise? Just as the DOE and DARPA subsidized scam science that aimed to outshine that of the communists, the CIA subsidized cultural endeavors that aimed to establish cultural superiority. From a documentary, I learned that when Dr. Zhivago, a god-awful labyrinthine 500-page disaster of a novel, won the Nobel Prize for Literature, it was given the award at the request of the CIA to score political points in the Cold War. The Soviet censors had supposedly rejected the novel because it didn't promote communist ideals. But given how bad the book was, it was probably rejected for more practical reasons. Prizes are awarded for terrible work all of the time, and I never could figure out why Samuel Beckett won a Nobel Prize for Literature. So, did the CIA play a role there as well? His chronically depressed writing reads at times like the work of a person with brain damage. He was, after all, institutionalized at a hospital called Tavistock in a time which was very much dominated by new advances in physical treatments like electroconvulsive therapy, otherwise known as shock therapy, and a drug called cardiazol. Was he a cautionary tale? I have the book Malone Dies, and the Unnameable on my bedside table, and I assure you that they have no plot whatsoever and are nearly unreadable noise. So this is fitting into a narrative I'm developing about how Nobel Prizes in physics are often given to score political points or to reward those who toed the big science party line. And I wonder if this is also happening in the cultural arena. People like this YouTube person named Skepchick come to mind. A while back, I was surprised to learn that this CIA effort to project cultural superiority extended into the world of art. For example, the CIA subsidized modernist art like the paintings of Jackson Pollock and de Kooning. In comparison to modern painting, modernist work often looks like it was created by people with brain damage. It derives much of its emotional power from that, but still, it is a frightening reflection of the modern mind, so full of noise that it can't think. I can't help but notice a striking similarity between a Jackson Pollock painting and with the measurements of the cosmic microwave background radiation. The rainbow is all jumbled up, and this somehow upsets my inner child, and that is where the emotional impact of both the art and the measurements draws its power. But why were they encouraging all of us to search for meaning within noise? Is noise all that they saw in their terror of the Cold War, and they wanted the rest of us to suffer the same fate? Was this the fear of a small community projected onto the population at large as a form of therapy for the people who had built and witnessed the awful power of the nuclear bomb? Was this a collective fear of losing a sense of cultural superiority? By projecting our fears onto others, we often try to exercise our fear of ourselves. By turning our fear against something external, we prevented ourselves from allowing our fear of inadequacy to consume us. If you are too busy being terrified that an attack will come from without, you'll never have the time to worry about an attack coming from within. If you outsource your thoughts to the noise of the group, you never need to think for yourself. You just defer to the group. If you drown your thoughts with the noise of cultural and scientific transformation, you'll never have to deal with uncomfortable thoughts at all. I'd rather see rainbows than noise, and if there is one thing I know for certain, it is that nothing lasts forever. The noise will not last forever. Someday we'll find it, the rainbow connection, the lovers, the dreamers, and me. Thank you for watching this video. Please tune in for my next one, and please take a look at the novels I wrote. I find that through literature you can express things that you simply can't say out loud, directly. And I felt like writing the novels helped me grow, and I think they would help others grow and provide some entertainment. They're a mix. Thanks again.